Hi guys, welcome back. Today we're going to do a quick overall review of the types of questions that you often get using tables. So first, they often ask about finding the derivative at a point on a table. So first thing with the tables, always make sure you look at the variables and make sure you know what they represent, okay? Obviously in this one I don't have any words, so I'm just going to do the mechanics. Okay, so if they ask for the derivative of whatever this title is, then remember that's your algebra 1 slope using 2 points surrounding it. So I would use these 2 points. And it's f of 7 minus f of 4 all over 7 minus 4. Okay? And then you do the math for that one. And then if they ask you to use units, make sure whatever these units are, the units on this would be like if this is feet and this was seconds, then it's going to be feet over seconds, feet per second. Make sure you write units if they ask you to, because if they tell you to specify the units, then that's a point, okay? Now, if for some reason this was already feet per second in the table, then when you do the derivative of feet per second, it would be feet per second squared. Just a little FYI. Okay, next thing. How do you know when they want you to do a derivative or if they want you to do an integral, okay? Derivative in words means they want the rate or how fast something is changing. Integral would be when they want the total of something. Like if they give you a rate of change and then like how fast people are waiting in line, and then they ask for the total number of people in line. All right, next, how do you estimate an integral on a graph? If they were to ask you to evaluate the integral of f of x from 1 to 9, okay, that means Riemann sums, different Riemann sums. So Riemann sums, left Riemann sum, right Riemann sum, midpoint rule, and trapezoid rule. Okay, and these are all on your justifications page. Hopefully you remember how to do a left Riemann sum. If it was a left Riemann sum, it would be 2 times the number on the left, which is 5, plus 1 times the number on the left, which was 8, and 3, number on the left is 9, and 2, number on the left is, I don't know, I covered it up and cannot see it anymore, 6. Okay, that's a left Riemann sum. If it was a right Riemann sum, this was a left Riemann sum. If it were a right Riemann sum, I would start on the right side, even though on the AP exam they typically show the answer starting on the left. It doesn't matter. I always start on the right. If it were a right Riemann sum, it would be 2, using the x's, 2 times the number on the right, and then 3 times the number on the right, and 1 times the number on the right. And you got to write that stupid 1. Don't forget, you have to write the 1 or they're dumb and they don't give you credit. And then 2 times the 8. That's a right Riemann sum. By the way, for multiple choice questions that'll be coming soon, sometimes they'll ask on a multiple choice question, what could be the value of this, given a table or something like that? When they say what could be the value, then what you do is find the left, find the right, and it can be any number in between. You find an underestimate and an overestimate, and it could be any number in between. Okay, trapezoid rule. I'll skip the midpoint for now. Trapezoid rule is 1/2 the height times the sum of the bases. Okay, 1/2 this height and the sum of the two bases, which are 5 and 8. So the area of each trapezoid added up. It's 1/2. The height is 2. Use both bases, 5 and 8. That's one trapezoid. That would be the area of this guy. All right, then you do 1/2. The height is 1. Use both 8 and 9. Okay, you see the pattern I've got going on here. Then it's 1/2 again of 3. Use the 9 and the 6. And last, 1/2 of 2. And use the 6 and the 4. Okay? It is quicker if you want to write the 1/2 just once out in front and use the factor it out. That's quicker. I write it every time just because I think people forget it. Okay, before I move on to the midpoint rule, now let's talk about how you justify if you use a Riemann sum or a trapezoid rule. How do you justify if your estimate, because these are always estimated integrals, how do we justify if it's an over and under estimate, okay? For a left or a right Riemann sum, it comes down to whether the function is increasing or decreasing, okay? So if it's a left or a right Riemann sum, it has to do with increasing or decreasing. So for this problem, first of all, they wouldn't ask it unless I change these numbers. I got to make this a 16, and maybe I'll make this, I guess I'll make it a 40. Okay, so if I used a left Riemann sum for this table, I would quickly look at the table and see if the numbers are going up or down, and these are increasing. Okay, so if they're increasing, draw a quick increasing curve. It doesn't even matter if it's concave up or concave down. Okay, and you'll see that in a minute. Okay, and then draw one rectangle that starts on the left side, and you'll see whether it's concave up or concave down. If it were an increasing curve, that's an underestimate. Okay. Now, don't memorize all 4 scenarios. Just know for Riemann sums, it has to do with first derivative, increasing or decreasing. And you'll have to say, because f of x is increasing, my left Riemann sum is an underestimate. Or just say, this is an underestimate. Okay? Now let's look at a right Riemann sum, but you don't really have to. It's the same concept. Just draw the scenario as it comes along each time. Now let's say you used this table to estimate the integral from 1 to 4, and they ask, is it increasing or decreasing? And you did a right Riemann sum. Okay, again, look at the function, figure out if it's increasing or decreasing. This one's decreasing. So quickly off to the side, draw a decreasing curve. Again, it doesn't matter if it's concave up or concave down. If I do a right Riemann sum, I'm going to start on the right side and make that the height of my rectangle. Okay, starting on the right side, make that the height of my rectangle. And you can see that this is an underestimate. Okay, but there are 4 different scenarios depending on increasing, decreasing, and left or right. So each time, just make sure you draw it. Okay, draw your increase. It comes down to, for left and right Riemann sums, it comes down to whether the curve is increasing or decreasing. Okay, what if you had an increasing function, boop, boop, and you did a right Riemann sum? Well, that means the height of it would be on the right side, and you can see that's an overestimate. Height on the right side, overestimate. So concavity does not matter for the left and right Riemann sums. All that matters is first derivative. Is your function increasing or decreasing? And then draw it real quick so you don't have to memorize. Okay, now justifying the trapezoid rule. Oh, okay, that's not how you spell trapezoid. Okay, for the trapezoid rule, it doesn't matter whether it's increasing or decreasing. For that one, it's concavity. Let me draw you a concave up versus a concave down curve, and these are both increasing. Now, draw a trapezoid. Pick 2 points, pew, pew, okay? And when I make that a trapezoid, okay, that's an overestimate of the area, okay? And now make this a trapezoid. And that is an underestimate. So for the trapezoid, similar to using an equation of a tangent because of this line, it comes down to concavity. So let's summarize all of that. If you are justifying a left or a right Riemann sum, okay, you have to use the first derivative, increasing or decreasing. You can say it in words, or you can symbolically say whether the derivative is positive or negative. Okay? If it is a trapezoid rule, you have to say the concavity, or concave up versus concave down, or you can just use the second derivative. Okay? Because a trapezoid rule has a line at the top, it's also similar to a tangent. When you use a tangent to estimate a value, same thing, it's the second derivative. Okay? This is how you justify estimates. And this is all also on the back page of the justification sheet I gave you. Okay, now a quick review of the midpoint rule. That's the one that I always end up having to graph because I'm dumb. So I'll take all my x's and write them down on my x-axis. 1, 2, 3, 4, and 5. And I'll just make random rectangles, okay? They say 2 subdivisions, so I'm going to make 2 rectangles. I don't even care if I draw them to the correct height. This just helps me visualize. When I do the midpoint rule, I'm using the height at the point in the middle. So the height of this rectangle is going to be the height at 2, which was 8. And this was the height at 4, which is 6. So I didn't draw them to scale. I don't care. So using the midpoint rule, the area would be 2 by 8 plus 2 by 6. Okay, that's a midpoint rule. And they don't usually ask you to justify whether it's an over or underestimate because it's it goes back and forth for midpoint rule. Okay, the next thing that you'll often see on a table problem is for you to find the average of something. So let's change this to more of a typical word problem. Let's say this is T and this guy's G of T. I don't know what G of T stands for. I don't know, number of goats, who knows? And then they ask for the average number of goats from T of 1 to T of 9, okay? If they ask for the average of something, you need to first add up all of the numbers, which would be the integral from 1 to 9 of G of T. That's adding up all of these values and the numbers in between, because we don't just want at 1 and at 3, we want all of the numbers, okay? So that's the total of the number of goats, the total, and now I need to divide by that number of numbers, and that's going to be 1 over 9 minus 1, okay? Average value. So this would be an average, 1/8 of the integral from 1 to 9 of G of T. This part of it you do with whatever Riemann sum they say, but you often have to interpret what does this mean. So if you see that fraction out front, what it means is that you are finding the average of whatever this thing's entitled, okay? That's what that means. And then they're going to be more specific. It's the average of whatever this is, and then also state the time frame from T of 1 to 9, or during the however many hours, okay? Okay, the last thing I have to refresh your memory on in order for you to understand the free response questions for today, I think, is when do you use MVT and IVT? Okay, mean value theorem. Please look back on your justification page and review both of these, okay? Mean value theorem is the one that says that the actual derivative at some point must equal the estimated derivative. Okay? IVT is the one that says if, say, at the beginning of your day the temperature is 70 and the end of your day the temperature is 79, then there must be a time somewhere where the temperature is, and they'll make up a number somewhere between 70 and 79, like, okay, yeah, it definitely hit 72. Okay, so when do you know when you're using these? Because they'll ask you to justify, and you got to state the actual theorem, MVT or IVT, and you can use initials. Well, if ever you say that, well, if this was an answer and this was an answer, so therefore an answer in between could work, that's IVT. Okay? If ever you estimate a derivative, this one has a derivative involved. This one has no derivatives in it. This one is a derivative symbol. So every time you estimate a derivative on a table, you're using MVT. You're estimating the derivative, and then you're saying, so therefore the actual derivative must be that also at some point. So every time you do an estimated derivative on a table, that's MVT. Every time you say, well, if that answer worked and that answer worked, then surely in between also works, that's IVT. Now, there are a couple of stipulations. MVT, you did a derivative. It must be differentiable. And if it's differentiable, it is also, by default, also continuous, okay? Now, this part where it's differentiable is usually written in the story, in the problem, up high at the top of the problem, okay? That differentiable word will be in the problem, okay? So if you say it's MVT, you have to also say it's differentiable because there's a derivative involved. IVT doesn't have a derivative involved. So all you have to say for that one is that it's continuous. Okay? Good luck with the 4 table problem FRQs today. And please, please, please let me know if you need some help. And remember, the more you take these problems seriously, the easier it gets. Okay? We're going to start doing multiple choice questions too very soon. Bye. Hope you're doing well.